Good evening, everyone. Today we are going to discuss about assignment 2. So this is question 1. You need to give specific example of 3 different type of vector quantity that you have experienced today. So first of all, you have to understand about what is vector quantity. So the vector quantity that we have learned is displacement, velocity, and maybe one more you can use force. So these are the reference answer that I give to you. You may refer or you may also give your own answer. So, and this is question 2. So, is it possible for total distance traveled to equal the magnitude of the displacement? If no, why not? If yes, give an example. So, what we need to discuss, focus is on total distance traveled and the magnitude of the displacement. Before you start the question, you have to understand the concept that if someone, Ali, went from point A to point B, and the distance is 100 meter, and then he go back to point C again, the distance here is 40 meter. Therefore, the total distance traveled should be 100 meter, and then you add 40 meter. So these are total distance traveled. But if we study or we measure the displacement of how Ali traveled, we should only measure about the initial position and the ending position, which is within this point, 60 meter. So from this concept, we extended this concept. Is it possible for total distance traveled to equal to the magnitude? The answer is yes. This is possible if you move in straight line without changing the direction. Means that you go from A to B without going back, then the distance traveled and the displacement will be same, 100 meter. So these are the examples you can read through. And for second questions, is it possible for the total distance traveled to exceed? Exceed means more than. Is it possible for total distance traveled more than the magnitude of displacement? The answer is yes. Okay, because that the total distance traveled can always exceed the magnitude of displacement, but cannot be less than. From the example given here, we can know that the total distance traveled from A to B and then from B to C is 140, but the displacement is where we calculated only from A, the starting point, and to C, the ending point, which is only 60 meter. So the total distance traveled is always exceed the displacement for this case if there's any changing direction occur. And then for third question, is it possible for the magnitude of the displacement to exceed the total distance traveled? The question says that, is it possible for displacement more than the total distance? So the answer is no, this is not possible. Why? Because this displacement is the shortest straight line distance between the starting and ending points. So the total distance traveled can never be less than the displacement. Okay, next, question 3. A city bus leaves the terminal and travel with a few stops along a straight route that takes 12 km to the east of its starting position in 24 minutes. In another 24 minutes, the bus turns around and retraces its path to the terminal, which means that the bus starting from point A and he's going to point B, then after that he going in this direction to the east, and then he go back again to this direction in the west. So here are the information given, and the question requires us to find the average speed of the bus. So we know that to find the average speed, we need to use the formula VAV equal to D divided by delta T. So the information that we have is 12 km to the east, 12 km, 12 km to the west. So that for this question, D is equal to 12 plus 12, the total is 24. And then the time taken is 24 minutes plus 24 minutes, so total is 48 minutes. But normally we measure the speed in km per hour. So we may also convert minute into hour by simply divided by 60. 48 divided by 60, the answer will be 0.8 hour. And then we just substitute the value of the distance and the time into the equation given. So VAV is equal to 24 km divided by 0.8 km. So the answer should be 24 divided by 0.8. So the answer is 30 km per hour. Sorry, this is hour. And then for B, you have to calculate the average velocity. Now we are dealing with velocity, which means that we need to know what is the farthest position from the terminal. So that the furthest position from the terminal is this is the starting point and this is the ending point. So VAV, we're using the same formula, is equal to D delta D divided by delta T. Why we are using delta D? Because now we are calculating velocity, and velocity is a vector quantity. Vector quantity means that for this unit we have direction. So the farthest position is from point A to point B, which is 12 km, and how long it take? 24 minutes. And normally we use minute in terms of hour, so we may divide 24 divided by 60 to find the what is the hour. (24) divided by 0 divided by 60, so the answer is 0.4 hour. So divided by 0.4 hour, the answer should be 12 divided by 0.4 is 30 km per hour. And then for C, find the average velocity of the bus for the entire route. If we wanted to find the average velocity of the entire route, means that the bus is now travel from point A to point B, and then travel back again from point B to point A. Therefore, the displacement is equal to 0, but the time is 0.8 hour. If the distance, the displacement is 0, therefore the average velocity should be 0. So why are your answer for B and C are different? B, we only calculated the distance from A to B, so the displacement is A to B to the east. And then for question C, the average velocity is 0 because the displacement is 0, since that as the initial position is same as the final position. For C, therefore the displacement is equal to 0. Okay, next. Question 4. A truck driver reacting quickly to an emergency applied the brakes. During the driver's 0.32 reaction time, the truck maintained a constant velocity of 27 meters per second forward. So what is the displacement of the truck during the time the driver takes to react? So now we have the information, which is a delta t equal to 0.32 seconds. And then we have a constant velocity. Velocity v is equal to 27 meters per second. So the question said, what is the displacement of the truck? So we just apply the formula. V is equal to delta d divided by, this one is forward, divided by time taken 0.32 seconds. So sorry, this one should be delta t first. And then we know that V is 27 meters per second forward, FWD, and then it's equal to the distance traveled. This is what we wanted to find. Okay, delta D is what we need to find, and then divided by the time taken 0.32. So the displacement should be 0.32 seconds times 27 meter per second to the forward. So the answer should be 0.328. So 0.32 second times 27. So the answer is 8.64 meter to the direction of forward. So that's the answer.